The Amazon rainforest, also called Amazon jungle or Amazonia, is a moist broadleaf tropical rainforest in the Amazon biome that covers most of the Amazon basin of South America. This basin encompasses 7 million square kilometers, of which 6 million square kilometers are covered by the rainforest. This region includes territory belonging to 9 nations and 3,344 formally acknowledged indigenous territories. The majority of the forest, 60%, is in Brazil, followed by Peru with 13%, Colombia with 10%, and with minor amounts in Bolivia, Ecuador, French Guiana, Guyana, Suriname, and Venezuela. 4 nations have Amazonas as the name of one of their first-level administrative regions, and France uses the name Guyana Amazonian Park for French Guyana's protected rainforest area. The Amazon represents over half of Earth's remaining rainforests, and comprises the largest and most biodiverse tract of tropical rainforest in the world, with an estimated 390 billion individual trees in about 16,000 species. More than 30 million people of 350 different ethnic groups live in the Amazon, which are subdivided into 9 different national political systems and 3,344 formally acknowledged indigenous territories. Indigenous peoples make up 9% of the total population, and 60 of the groups remain largely isolated. Large-scale deforestation is occurring in the forest, creating different harmful effects. Economic losses due to deforestation in Brazil could be approximately 7 times higher in comparison to the cost of all commodities produced through deforestation. In 2023, the World Bank published a report proposing a non-deforestation-based economic program in the region. Etymology. The name Amazon is said to arise from a war Francisco de Orellana fought with the Tapuyas and other tribes. The women of the tribe fought alongside the men, as was their custom. Orellana derived the name Amazonas from the Amazons of Greek mythology, described by Herodotus and Diodorus. History. Based on archaeological evidence from an excavation at Caverna da Pedra Pintada, human inhabitants first settled in the Amazon region at least 11,200 years ago. Subsequent development led to late prehistoric settlements along the periphery of the forest by AD 1250, which induced alterations in the forest cover. For a long time, it was thought that the Amazon rainforest was never more than sparsely populated, as it was impossible to sustain a large population through agriculture given the poor soil. Archaeologist Betty Meggers was a prominent proponent of this idea, as described in her book Amazonia, Man and Culture in a Counterfeit Paradise. She claimed that a population density of 0.2 inhabitants per square kilometer is the maximum that can be sustained in the rainforest through hunting, with agriculture needed to host a larger population. However, recent anthropological findings have suggested that the region was actually densely populated. The Upano Valley sites in present-day eastern Ecuador predate all known complex Amazonian societies. Some 5 million people may have lived in the Amazon region in AD 1500, divided between dense coastal settlements, such as that at Marajo, and inland dwellers. Based on projections of food production, one estimate suggests over 8 million people living in the Amazon in 1492. By 1900, the native indigenous population had fallen to 1 million, and by the early 1980s it was less than 200,000. The first European to travel the length of the Amazon River was Francisco de Orellana in 1542. The BBC's Unnatural Histories presents evidence that Orellana, rather than exaggerating his claims as previously thought, was correct in his observations that a complex civilization was flourishing along the Amazon in the 1540s. The pre-Columbian agriculture in the Amazon basin was sufficiently advanced to support prosperous and populous societies. It is believed that civilization was later devastated by the spread of diseases from Europe, such as smallpox. This civilization was investigated by the British explorer Percy Fawcett in the early 20th century. The results of his expeditions were inconclusive, and he disappeared mysteriously on his last trip. His name for this lost civilization was the city of Z. Since the 1970s, numerous geoglyphs have been discovered on deforested land dating between AD 1 to 1250, furthering claims about pre-Columbian civilizations. Ondamar Dias is accredited with first discovering the geoglyphs in 1977, and Alsu Ranzi is credited with furthering their discovery after flying over Acre. The BBC's Unnatural Histories presented evidence that the Amazon rainforest, rather than being a pristine wilderness, has been shaped by man for at least 11,000 years through practices such as forest gardening and terra preta. Terra preta is found over large areas in the Amazon forest, and is now widely accepted as a product of indigenous soil management. The development of this fertile soil allowed agriculture and silviculture in the previously hostile environment, meaning that large portions of the Amazon rainforest are probably the result of centuries of human management, rather than naturally occurring as has previously been supposed. In the region of the Xingu tribe, remains of some of these large settlements in the middle of the Amazon forest were found in 2003 by Michael Heckenberger and colleagues of the University of Florida. Among those were evidence of roads, bridges, and large plazas. In the Amazonas, there has been fighting and wars between the neighboring tribes of the Jivaro. Several tribes of the Jivaroan group, including the Shuar, practiced head hunting for trophies and head shrinking. The accounts of missionaries to the area in the borderlands between Brazil and Venezuela have recounted constant infighting in the Yanomami tribes. More than a third of the Yanomamo males, on average, died from warfare. The Mundurika were a warlike tribe that expanded along the Tapajos River and its tributaries and were feared by neighboring tribes. In the early 19th century, the Mundurika were pacified and subjugated by the Brazilians. During the Amazon rubber boom, it is estimated that diseases brought by immigrants, such as typhus and malaria, killed 40,000 native Amazonians. In the 1950s, Brazilian explorer and defender of indigenous people, Candido Rondon, supported the Vilas Boas Brothers campaign, which faced strong opposition from the government and the ranchers of Mato Grosso and led to the establishment of the first Brazilian national park for indigenous people along the Xingu River in 1961. In 1961, British explorer Richard Mason was killed by an uncontacted Amazon tribe known as the Panara. The Matsas made their first permanent contact with the outside world in 1969. Before that date, they were effectively at war with the Peruvian government. Geography. 9 countries share the Amazon basin. Most of the rainforest, 58.4%, is contained within the borders of Brazil. The other 8 countries are Peru with 12.8%, Bolivia with 8%, Colombia with 7.1%, Venezuela with 6%, Guyana with 3%, Suriname with 2.5%, French Guiana with 1.4% and Ecuador with 1%. The rainforest likely formed during the Eocene era from 56 million years to 33.9 million years ago. It appeared following a global reduction of tropical temperatures when the Atlantic Ocean had widened sufficiently to provide a warm, moist climate to the Amazon basin. The rainforest has been in existence for at least 55 million years, and most of the region remained free of savanna-type biomes at least until the current ice age, when the climate was drier and savanna more widespread. Following the Cretaceous, Paleogene extinction event, the extinction of the dinosaurs and the wetter climate may have allowed the tropical rainforest to spread out across the continent. From 66 to 34 Maya, the rainforest extended as far south as 45 degrees. Climate fluctuations during the last 34 million years have allowed savanna regions to expand into the tropics. During the Oligocene, for example, the rainforests spanned a relatively narrow band. It expanded again during the Middle Miocene, then retracted to a mostly inland formation at the last glacial maximum. However, the rainforests still managed to thrive during these glacial periods, allowing for the survival and evolution of a broad diversity of species. During the Mid-Eocene, it is believed that the drainage basin of the Amazon was split along the middle of the continent by the Purus Arch. Water on the eastern side flowed toward the Atlantic, while to the west water flowed toward the Pacific across the Amazonas basin. As the Andes Mountains rose, however, a large basin was created that enclosed a lake, now known as the Solomos Basin. Within the last 5 to 10 million years, this accumulating water broke through the Purus Arch, joining the easterly flow toward the Atlantic. There is evidence that there have been significant changes in the Amazon rainforest vegetation over the last 21,000 years through the last glacial maximum and subsequent deglaciation. Analyses of sediment deposits from Amazon basin paleolakes and the Amazon fan indicate that rainfall in the basin during the LGM was lower than for the present, and this was almost certainly associated with reduced moist tropical vegetation cover in the basin. In present day, the Amazon receives approximately 9 feet of rainfall annually. There is a debate, however, over how extensive this reduction was. Some scientists argue that the rainforest was reduced to small, isolated refugia separated by open forest and grassland. Other scientists argue that the rainforest remained largely intact but extended less far to the north, south, and east than is seen today. This debate has proved difficult to resolve because the practical limitations of working in the rainforest mean that data sampling is biased away from the center of the Amazon basin, and both explanations are reasonably well supported by the available data. More than 56% of the dust fertilizing the Amazon rainforest comes from the Bodil Depression in northern Chad in the Sahara Desert. The dust contains phosphorus, important for plant growth. The yearly Sahara dust replaces the equivalent amount of phosphorus washed away yearly in Amazon soil from rains and floods. NASA's Calypso satellite has measured the amount of dust transported by wind from the Sahara to the Amazon. An average of 182 million tons of dust are windblown out of the Sahara each year, at 15 degrees west longitude, across 2,600 kilometers over the Atlantic Ocean, then at 35 degrees west longitude at the eastern coast of South America. 27.7 million tons of dust fall over the Amazon basin, 132 million tons of dust remain in the air, 43 million tons of dust are windblown and falls on the Caribbean Sea, past 75 degrees west longitude. Calypso uses a laser rangefinder to scan the Earth's atmosphere for the vertical distribution of dust and other aerosols. Calypso regularly tracks the Sahara-Amazon dust plume. Calypso has measured variations in the dust amounts transported, an 86% drop between the highest amount of dust transported in 2007 and the lowest in 2011. A possibility causing the variation is the Sahel, a strip of semi-arid land on the southern border of the Sahara. When rain amounts in the Sahel are higher, the volume of dust is lower. The higher rainfall could make more vegetation grow in the Sahel, leaving less sand exposed to winds to blow away. Amazon phosphorus also comes as smoke due to biomass burning in Africa. Wet tropical forests are the most species-rich biome, and tropical forests in the Americas are consistently more species-rich than the wet forests in Africa and Asia. As the largest tract of tropical rainforest in the Americas, the Amazonian rainforests have unparalleled biodiversity. 1 in 10 known species in the world lives in the Amazon rainforest. This constitutes the largest collection of living plants and animal species in the world. The region is home to about 2.5 million insect species, tens of thousands of plants, and some 2,000 birds and mammals. To date, at least 40,000 plant species, 2,200 fishes, 1,294 birds, 427 mammals, 428 amphibians, and 378 reptiles have been scientifically classified in the region. 1 in 5 of all bird species are found in the Amazon rainforest, and 1 in 5 of the fish species live in Amazonian rivers and streams. Scientists have described between 96,660 and 128,843 invertebrate species in Brazil alone. The biodiversity of plant species is the highest on Earth, with one 2001 study finding a quarter square kilometer of Ecuadorian rainforest supports more than 1,100 tree species. A study in 1999 found 1 square kilometer of Amazon rainforest can contain about 90,790 tons of living plants. The average plant biomass is estimated at 356 plus or minus 47 tons per hectare. To date, an estimated 438,000 species of plants of economic and social interest have been registered in the region, with many more remaining to be discovered or catalogued. The total number of tree species in the region is estimated at 16,000. The green leaf area of plants and trees in the rainforest varies by about 25% as a result of seasonal changes. Leaves expand during the dry season when sunlight is at a maximum, then undergo abscission in the cloudy wet season. These changes provide a balance of carbon between photosynthesis and respiration. Each hectare of the Amazon rainforest contains around 1 billion of invertebrates. The amount of species per hectare in the Amazon rainforest can be presented in the next table. The rainforest contains several species that can pose a hazard. Among the largest predatory creatures are the black caiman, jaguar, cougar, and anaconda. In the river, electric eels can produce an electric shock that can stun or kill, while piranha are known to bite and injure humans. Various species of poison dart frogs secrete lipophilic alkaloid toxins through their flesh. There are also numerous parasites and disease vectors. Vampire bats dwell in the rainforest and can spread the rabies virus. Malaria, yellow fever, and dengue fever can also be contracted in the Amazon region. The biodiversity in the Amazon is becoming increasingly threatened, primarily by habitat loss from deforestation as well as increased frequency of fires. Over 90% of Amazonian plant and vertebrate species may have been impacted to some degree by fires. Overall, 20% of the Amazon rainforest has been transformed and another 6% has been highly degraded, causing Amazon Watch to warn that the Amazonia is in the midst of a tipping point crisis. Deforestation is the conversion of forested areas to non-forested areas. The main sources of deforestation in the Amazon are human settlement and the development of the land. In 2022, about 20% of the Amazon rainforest has already been deforested and a further 6% was highly degraded. Research suggests that upon reaching about 2022, the tipping point to flip it into a non-forest ecosystem, degraded savanna, in eastern, southern and central Amazonia will be reached. This process of savannization would take decades to take full effect. Prior to the early 1960s, access to the forest's interior was highly restricted, and the forest remained basically intact. Farms established during the 1960s were based on crop cultivation and the slash-and-burn method. However, the colonists were unable to manage their fields and the crops because of the loss of soil fertility and weed invasion. The soils in the Amazon are productive for just a short period of time, so farmers are constantly moving to new areas and clearing more land. These farming practices led to deforestation and caused extensive environmental damage. Deforestation is considerable, and areas cleared of forest are visible to the naked eye from outer space. In the 1970s, construction began on the Trans-Amazonian Highway. This highway represented a major threat to the Amazon rainforest. The highway still has not been completed, limiting the environmental damage. Between 1991 and 2000, the total area of forest lost in the Amazon rose from 415,000 to 587,000 square kilometers, with most of the lost forest becoming pasture for cattle. 70% of formerly forested land in the Amazon, and 91% of land deforested since 1970, have been used for livestock pasture. Currently, Brazil is the largest global producer of soybeans. New research, however, conducted by Ladeimara Oliveira et al. Has shown that the more rainforest is logged in the Amazon, the less precipitation reaches the area, and so the lower the yield per hectare becomes. So despite the popular perception, there has been no economical advantage for Brazil from logging rainforest zones and converting these to pastoral fields. The needs of soy farmers have been used to justify many of the controversial transportation projects that are currently developing in the Amazon. The first two highways successfully opened up the rainforest and led to increased settlement and deforestation. The mean annual deforestation rate from 2000 to 2005 was 18% higher than in the previous 5 years. Although deforestation declined significantly in the Brazilian Amazon between 2004 and 2014, there has been an increase to the present day. Brazil's president, Jair Bolsonaro, has supported the relaxation of regulations placed on agricultural land. He has used his time in office to allow for more deforestation and more exploitation of the Amazon's rich natural resources. Since the discovery of fossil fuel reservoirs in the Amazon rainforest, oil drilling activity has steadily increased, peaking in the western Amazon in the 1970s and ushering another drilling boom in the 2000s. Oil companies have to set up their operations by opening new roads through the forests, which often contributes to deforestation in the region. The European Union, Mercosur Free Trade Agreement, which would form one of the world's largest free trade areas, has been denounced by environmental activists and indigenous rights campaigners. The fear is that the deal could lead to more deforestation of the Amazon rainforest as it expands market access to Brazilian beef. According to a November 2021 report by Brazil's INPE, based on satellite data, deforestation has increased by 22% over 2020 and is at its highest level since 2006. There were 72,843 fires in Brazil in 2019, with more than half within the Amazon region. In August 2019 there were a record number of fires. Deforestation in the Brazilian Amazon rose more than 88% in June 2019 compared with the same month in 2018. The increased area of fire-impacted forest coincided with the relaxation of environmental regulations from the Brazilian government. Notably, before those regulations were put in place in 2008, the fire-impacted area was also larger compared to the regulation period of 2009 to 2018. As these fires continue to move closer to the heart of the Amazon basin, their impact on biodiversity will only increase in scale, as the cumulative fire-impacted area is correlated with the number of species impacted. Conservation and climate change. Environmentalists are concerned about loss of biodiversity that will result from destruction of the forest, and also about the release of the carbon contained within the vegetation, which could accelerate global warming. Amazonian evergreen forests account for about 10% of the world's terrestrial primary productivity and 10% of the carbon stores in ecosystems. Amazonian forests are estimated to have accumulated 0.62 plus or minus 0.37 tons of carbon per hectare per year between 1975 and 1996. In 2021 it was reported that the Amazon for the first time emitted more greenhouse gases than it absorbed. Though often referenced as producing more than a quarter of the Earth's oxygen, this often stated, but misused statistic actually refers to oxygen turnover. The net contribution of the ecosystem is approximately zero. One computer model of future climate change caused by greenhouse gas emissions shows that the Amazon rainforest could become unsustainable under conditions of severely reduced rainfall and increased temperatures, leading to an almost complete loss of rainforest cover in the basin by 2100. And severe economic, natural capital and ecosystem services impacts of not averting the tipping point. However, simulations of Amazon basin climate change across many different models are not consistent in their estimation of any rainfall response, ranging from weak increases to strong decreases. The result indicates that the rainforest could be threatened through the 21st century by climate change in addition to deforestation. In 1989, environmentalist C.M. Peters and two colleagues stated there is economic as well as biological incentive to protecting the rainforest. 1 hectare in the Peruvian Amazon has been calculated to have a value of $68.20 if intact forest is sustainably harvested for fruits, latex, and timber, $1,000 if clear-cut for commercial timber not sustainably harvested, or $148 if used as cattle pasture. As indigenous territories continue to be destroyed by deforestation and ecocides such as in the Peruvian Amazon, indigenous peoples' rainforest communities continue to disappear, while others, like the Urarana, continue to struggle to fight for their cultural survival and the fate of their forested territories. Meanwhile, the relationship between non-human primates in the subsistence and symbolism of indigenous lowland South American peoples has gained increased attention, as have ethnobiology and community-based conservation efforts. From 2002 to 2006, the conserved land in the Amazon rainforest almost tripled and deforestation rates dropped up to 60%. About 1 million square kilometers have been put onto some sort of conservation, which adds up to a current amount of 1,730,000 square kilometers. In April 2019, the Ecuadorian court stopped oil exploration activities in 180,000 hectares of the Amazon rainforest. In July 2019, the Ecuadorian court forbade the government to sell territory with forests to oil companies. In September 2019, the US and Brazil agreed to promote private sector development in the Amazon. They also pledged a 100 M biodiversity conservation fund for the Amazon led by the private sector. Brazil's foreign minister stated that opening the rainforest to economic development was the only way to protect it. A 2009 study found that a 4 degrees Celsius rise above pre-industrial levels in global temperatures by 2100 would kill 85% of the Amazon rainforest, while a temperature rise of 3 degrees Celsius would kill some 75% of the Amazon. A new study by an international team of environmental scientists in the Brazilian Amazon shows that protection of freshwater biodiversity can be increased by up to 600% through integrated freshwater terrestrial planning. Deforestation in the Amazon rainforest region has a negative impact on local climate. It was one of the main causes of the severe drought of 2014 to 2015 in Brazil. This is because the moisture from the forests is important to the rainfall in Brazil, Paraguay, and Argentina. Half of the rainfall in the Amazon area is produced by the forests. Results of a 2021 scientific synthesis indicate that, in terms of global warming, the Amazon basin with the Amazon rainforest is currently emitting more greenhouse gases than it absorbs overall. Climate change impacts and human activities in the area, mainly wildfires, current land use, and deforestation, are causing a release of forcing agents that likely result in a net warming effect. In 2022, the Supreme Court of Ecuador decided that under no circumstances can a project be carried out that generates excessive sacrifices to the collective rights of communities and nature. It also required the government to respect the opinion of indigenous peoples of the Americas about different industrial projects on their land. Advocates of the decision argue that it will have consequences far beyond Ecuador. In general, ecosystems are in better shape when indigenous peoples own or manage the land. Due to the conservation policies of Luiz Inácio Lula da Silva in the first 10 months of 2023, deforestation in the Brazilian Amazon decreased by around 50% compared to the same period in 2022. This was despite a severe drought, one of the worst on record, that exacerbated the situation. Climate change, El Niño, deforestation increases the likelihood of drought condition in the Amazon. According to Amazon Conservation's MAAP Forest Monitoring Program, the deforestation rate in the Amazon from the January 1 to November 8, 2023, decreased by 56% in comparison to the same period in 2022. The main cause is the decline in deforestation rate in Brazil, due to the government's policies, while Colombia, Peru, and Bolivia also reduced deforestation. In January 2024, published data showed a 50% decline in deforestation rate in the Amazon rainforest and 43% rise in vegetation loss in the neighbor Cerrado during the year of 2023 in comparison to 2022. Both biomes together lose 12,980 square kilometers, 18% less than in 2022. The use of remotely sensed data is dramatically improving conservationists' knowledge of the Amazon basin. Given the objectivity and lowered costs of satellite-based land cover and change analysis, it appears likely that remote sensing technology will be an integral part of assessing the extents, locations, and damage of deforestation in the basin. Furthermore, remote sensing is the best and perhaps only possible way to study the Amazon on a large scale. The use of remote sensing for the conservation of the Amazon is also being used by the indigenous tribes of the basin to protect their tribal lands from commercial interests. Using handheld GPS devices and programs like Google Earth, members of the Trio tribe, who live in the rainforests of southern Suriname, map out their ancestral lands to help strengthen their territorial claims. Currently, most tribes in the Amazon do not have clearly defined boundaries, making it easier for commercial ventures to target their territories. To accurately map the Amazon's biomass and subsequent carbon-related emissions, the classification of tree growth stages within different parts of the forest is crucial. In 2006, Tatiana Kuklik organized the trees of the Amazon into 4 categories: mature forest, regenerating forest less than 3 years, regenerating forest between 3 and 5 years of regrowth, and regenerating forest 11 to 18 years of continued development. The researcher used a combination of synthetic aperture radar and thematic mapper to accurately place the different portions of the Amazon into one of the 4 classifications. Impact of early 21st century Amazon droughts. In 2005, parts of the Amazon basin experienced the worst drought in 100 years, and there were indications that 2006 may have been a second successive year of drought. A 2006 article in the UK newspaper The Independent reported the Woods Hole Research Centre results, showing that the forest in its present form could survive only 3 years of drought. Scientists at the Brazilian National Institute of Amazonian Research argued in the article that this drought response, coupled with the effects of deforestation on regional climate, are pushing the rainforest towards a tipping point where it would irreversibly start to die. It concluded that the forest is on the brink of being turned into savanna or desert, with catastrophic consequences for the world's climate. A study published in Nature Communications in October 2020 found that about 40% of the Amazon rainforest is at risk of becoming a savanna-like ecosystem due to reduced rainfall. A study published in Nature Climate Change provided direct empirical evidence that more than 3/4 of the Amazon rainforest has been losing resilience since the early 2000s, risking dieback with profound implications for biodiversity, carbon storage, and climate change at a global scale. According to the Worldwide Fund for Nature, the combination of climate change and deforestation increases the drying effect of dead trees that fuels forest fires. In 2010, the Amazon rainforest experienced another severe drought, in some ways more extreme than the 2005 drought. The affected region was approximately 3 million square kilometers of rainforest, compared with 1,900,000 square kilometers in 2005. The 2010 drought had 3 epicenters where vegetation died off, whereas in 2005, the drought was focused on the southwestern part. The findings were published in the journal Science. In a typical year, the Amazon absorbs 1.5 gigatons of carbon dioxide. During 2005 instead 5 gigatons were released, and in 2010 8 gigatons were released. Additional severe droughts occurred in 2010, 2015, and 2016. In 2019 Brazil's protections of the Amazon rainforest were slashed, resulting in a severe loss of trees. According to Brazil's National Institute for Space Research, deforestation in the Brazilian Amazon rose more than 50% in the first 3 months of 2020 compared to the same 3-month period in 2019. In 2020, a 17% rise was noted in the Amazon wildfires, marking the worst start to the fire season in a decade. The first 10 days of August 2020 witnessed 10,136 fires. An analysis of the government figures reflected 81% increase in fires in federal reserves, in comparison with the same period in 2019. However, President Jair Bolsonaro turned down the existence of fires, calling it a lie, despite the data produced by his own government. Satellites in September recorded 32,017 hotspots in the world's largest rainforest, a 61% rise from the same month in 2019. In addition, October saw a huge surge in the number of hotspots in the forest, with more than double the amount detected in the same month last year. Possibility of forest-friendly economy. In 2023 the World Bank published a report named, A Balancing Act for Brazil's Amazonian States, an Economic Memorandum. The report stating that economic losses due to deforestation in Brazil could reach around $317 billion per year, approximately 7 times higher in comparison to the cost of all commodities produced through deforestation, proposed non-deforestation-based economic program in the region of the Amazon rainforest. According to WWF, ecotourism could help the Amazon to reduce deforestation and climate change. Ecotourism is currently still little practiced in the Amazon, partly due to lack of information about places where implementation is possible. Ecotourism is a sector that can also be taken up by the indigenous community in the Amazon as a source of income and revenue. An ecotourism project in the Brazilian section of the rainforest had been under consideration by Brazil's State Secretary for the Environment and Sustainable Development in 2009, along the Arapuana River, in the Arapuana Sustainable Development Reserve. Also, some community-based ecotourism exists in the Mamiraua Sustainable Development Reserve. Ecotourism is also practiced in the Peruvian section of the rainforest. A few ecologies are for instance present between Cusco and Madre de Dios. In May 2023 Brazil's Bank Federation decided to implement a new sustainability standard demanding from meat packers to ensure their meat is not coming from illegally deforested area. Credits will not be given to those who will not meet the new standards. The decision came after the European Union decides to implement regulations to stop deforestation. Brazil beef exporters, said the standard is not just because it is not applied to landowners. 21 banks representing 81% of the credit market in Brazil agreed to follow those rules. According to a statement of the Colombian government, deforestation rates in the Colombian Amazon fell by 70% in the first 9 months of 2023 compared to the same period in the previous year, what can be attributed to the conservation policies of the government. One of them is paying local residents for conserving the forest.